The AI bubble may not be in ChatGPT. It may be hiding inside hundreds of billions of dollars being poured into data centers. Because right now, some of the biggest companies in the world are spending more money on AI faster than they're proving they can make it back.
So Google wants $85 billion, SpaceX wants $75 billion, Anthropic has already raised privately $65 billion, is preparing for offering the public market. That's going to be tens of billions. OpenAI, also tens of billions.
And if that bet goes wrong, the technology may survive, but the investors might not. The visible AI boom is easy to understand. Chatbots answer customers, coding assistants write software, legal tools summarize contracts, marketing teams generate copy in seconds. The demand is real, and pretending otherwise misses the point. But the apps are only the surface. The deeper you go, the more the AI boom stops looking like a software story and starts looking like something heavier. Chip orders, data center construction, cloud contracts worth hundreds of billions over a decade, power grid negotiations, private equity funds dedicated entirely to AI infrastructure. Think of it like a gold rush, but not the version where everyone talks about the miners. The reliable fortunes in a gold rush tend to go to the people selling shovels, controlling the land, running the transport, building the towns. The miners may or may not strike gold. The suppliers get paid while everyone is still digging. That is the architecture of the AI boom right now. The public sees the products, the money is building machinery. And the strange part is that the companies selling the machinery can get paid long before anyone knows whether the final AI business can justify the cost. To understand the first imbalance in the AI boom, start with Nvidia. The biggest winner so far is not necessarily the company with the best chatbot. It is the company selling the machinery every chatbot needs to exist. Frontier AI runs on compute, and Nvidia controls much of the hardware that makes that compute possible. If AI models are engines, Nvidia sells the fuel system. The more companies race to build, train, and serve larger models, the more demand flows toward the supplier underneath the entire stack. That is why Nvidia can benefit before the final AI business model is fully proven. Recently, Nvidia completed a $25 billion bond insurance after very strong investor demand. That does not mean Nvidia is in trouble. It shows something more interesting. Even the strongest infrastructure player in AI is now part of the financial architecture surrounding the boom. The first strange thing is this: the companies selling the picks, power, and machinery may win before the companies using them prove they can make enough money. Then the numbers stop sounding like software numbers. AI infrastructure is no longer being funded like a normal startup race. It is pulling in private equity, private credit, utility companies, chip suppliers, and structured finance at a scale more commonly associated with airports, pipelines, and power grids. Anthropic is tied to a $35 billion AI compute capacity expansion, financed by Apollo and Blackstone, built on Broadcom custom chips and networking. The first phase alone targets more than 1 gigawatt of compute capacity. Pause on that for a second. One AI company's expansion is being measured in gigawatts. Not users, not downloads, not monthly subscriptions. Gigawatts. At the same time, KKR launched Helix Digital Infrastructure with over $10 billion of committed capital, working alongside Nvidia and the energy company Vistra. These are industrial bets, not merely investments. The right image for a data center is not a server room. It is a factory. A factory where electricity goes in and intelligence comes out. Tokens, predictions, decisions, images, answers at industrial scale, continuously around the clock. And factories financed with debt carry a different kind of pressure. A startup can pivot. A software team can change direction. A product can be shut down. But a half-built data center, a signed power contract, or a multi-billion-dollar compute commitment does not disappear because the economics changed. Once the machinery is built, the future has to show up and pay for it. And this cost problem does not only exist at the level of billion-dollar data centers, it also shows up inside the AI apps themselves. Because sometimes the cheapest way to make AI faster is not to build more compute, it is to stop making the model repeat work it has already done. That is where BetterDB comes in. BetterDB helps AI remember past answers so they don't have to redo the same work again. If someone asks the exact same question, it can instantly return the previous answer. And even if the question is slightly different but means the same thing, it can still reuse that earlier result instead of calling the AI again. The result is simple: fewer wasted AI calls, faster responses, and lower costs. It also shows you how much work is being saved, so you can clearly see where your AI system is wasting time and money. You can try their live demo or learn more from the link in the description. Now, zoom back out from the app layer to the physical layer, because this cost problem becomes even more serious when you look at power. This is where the AI boom becomes physical. Anthropic's initial compute expansion involves more than 1 gigawatt of capacity. 1 gigawatt is roughly enough electricity to power 750,000 homes. This is not a server room. This is a city-scale energy demand attached to one AI build-out. And across the industry, the pressure multiplies. Power availability is now a strategic constraint. Grid connections in some regions can take years. Some areas cannot support new large-scale data centers fast enough because the infrastructure does not exist yet to feed them. And this is the thing that gets lost when AI is described in terms of prompts and models and applications. A prompt looks weightless. It looks like text. But behind it is a chain of chips, cooling systems, substations, backup generators, and transmission lines consuming electricity at industrial scale. From every query, from every user, every hour of every day. If the future of AI depends on building at the scale of power grids, the business model cannot just be promising. It has to be enormous.
I wonder whether it's FOMO, fear of missing out, rather than looking at the balance sheet, working out what the profitability might be in a couple of years, what your return on investment might be. I mean, we are seeing some of the biggest investors in the world deliberately steering clear of the AI space.
Given everything, the debt, the infrastructure, the energy demands, a reasonable question is, why does the spending keep accelerating? The answer is not that everyone has stopped thinking clearly. The answer is that from inside the race, slowing down may feel more dangerous than overspending. If AI becomes the next major computing platform, the way cloud or mobile computing reshaped everything before it, then being caught underbuilt is not a setback, it is potentially existential. Cloud revenue, search dominance, enterprise software, advertising systems, customer products, all of it can be restructured by whoever wins the AI infrastructure race. Model companies need more compute to stay at the frontier. Cloud providers need to lock in future workloads. Infrastructure firms benefit from continued expansion regardless of which applications eventually win. Picture every driver in the race watching the fuel gauge drop. Each one can see it. None of them wants to be the first to ease off because easing off means falling behind, and falling behind in a platform race can mean irrelevance. The spending may be dangerous, but from inside the machine, stopping first feels even more dangerous. This is where the central equation finally comes into view. Can AI revenue grow faster than AI compute cost? OpenAI has been reported to exceed $20 billion in annualized revenue in 2025, with compute spending targets reportedly approaching $600 billion through 2030. Anthropic has shown rapid run rate revenue growth and major enterprise customer expansion. So the demand is not imaginary, but demand and profitability are not the same thing. Training frontier models is expensive. Running interference at scale is expensive. Serving enterprise customers, improving models faster than competitors, and securing enough compute to stay relevant, all of it is expensive. And the cost does not stay flat, it rises with ambition. A packed restaurant can still fail if every meal costs more to make than the customer pays. That is the uncomfortable possibility in AI. The product can be popular, the revenue can grow, the demand can be real, and the economics can still become dangerous if the cost of serving that demand rises too quickly. The most uncomfortable version of the AI bubble is not that nobody wants the product, it is that everyone wants the product, and the cost of producing it keeps rising with how good it gets. The hardest bubbles to see are the ones built on something real. That is why the AI debate gets so confusing. People treat real technology and bubble like opposites, but history does not work that way. A technology can be useful, transformative, and permanent, while the money around it still becomes reckless. The internet was real. The dot-com bubble still happened. Railroads were real and they reshaped civilization, but railway manias in the 19th century still produced waves of overbuilding and financial collapse. Housing was real, the crisis still came. Some economists describe the current AI cycle as a real technological revolution with localized bubble dynamics. That phrase matters because it avoids the lazy version of the argument. It does not say AI is fake, it says the danger may be concentrated in specific places. Valuations, debt structures, data center projects, and assumptions about how quickly AI will pay back the infrastructure being built for it. The image is a bridge being built quickly on borrowed money. The bridge may matter, the destination may be real, but if the financing was structured around traffic that is not arrived yet, the project still becomes a problem. The believers may be right about the technology and still wrong about the price.
There's definitely a possibility, at least empirically based on past large infrastructure build-outs and how they led to bubbles, that something like that would happen here.
So, if the boom continues, who wins first? Probably not every AI app. Probably not every startup with AI in the pitch deck. The most insulated players are the ones selling the infrastructure underneath. Chip suppliers, cloud providers, data center operators, utilities, power companies, and private credit firms financing the build-out. They can get paid while the application layer is still trying to prove the final business model. The exposed players look different. AI startups carrying huge compute commitments before revenue is durable, late investors who entered at stretched valuations, companies that used AI strategy as a press release instead of building real products. Data center projects sized for demand that may not arrive on the timeline the depth requires. Those are the places where a correction would show up first. But the final frame is not really about whether AI survives. AI does not have to be fake for the bubble risk to be real. The models can keep improving, the products can keep spreading, technology can still change the economy. But if the correction comes, it may expose the difference between two very different groups. The companies building durable value and the companies borrowing against a future that had not arrived yet. The internet survived the dot-com crash. Railroads survived railway manias. Housing survived the housing bubble. The technology often survives, the financing around it does not always survive with it. AI may follow the same pattern. The question is not whether AI survives, the question is who survives the cost of making it real. If you want more grounded breakdowns of where AI is really heading, subscribe for the next one.